Okay, so our standard form of a hyperbola, okay, that will either show up, okay, that'll either show up as x minus 8 quantity squared over a squared plus minus y minus k squared over b squared, or you might see it as y minus k squared over a squared minus x minus 8 squared over b squared equals 1. Okay, so depending on which one is positive, you write your positive term first. So your x squared, your x terms are positive, x squared term is positive. You write that first. Your y squared term is first. You write that first. A is always the number underneath the first term. Okay, so that one doesn't, so A and B doesn't change like what the left did. Okay, so that's our standard form. Now, when we do this, we can always find our pieces of our equation. We can find our center, and our center is just h comma k, regardless of which form, h comma k or h comma k. That will be our center. That would be. If our if our x term is written first, our parabola will open, or hyperbola will open to the left and the right. That means that you're going to have a graph that looks like this if the x squared term is written first. If the y squared term is written first, it will open up and down. So that means we're going to have a graph that looks like this at the end. So that's the first thing you're going to look at. So you need to figure out which direction is opening, because that's going to help us figure out our vertices. Okay, so in blue, I'm going to do it if it's the x squared term is positive. I'm going to do those options in blue. And if the y squared term is positive, I'll show you that formula in purple. Okay. So finding our vertices changes based on which form we're doing. If it opens left and right, one thing we know, and this helps you think about it. So think of your graph and help you remember which way to go. Is we know that our center is the point in between the two U's. Okay, that's where our center is located at. Center are vertices. The center, there's my vertices, and my foci are always on a straight line. So here, if it's opening left and right, I have a center, my two vertices, and my two foci will be changing. My x values will be changing. As here, my center again, the two U's. My vertices are the vertex of the foci is right inside into the U's. Off there. It's always on a line. And so here, this is y. That's going to help us remember which formula to use. If it's opening left and right, our x's change, but they'll stay the same. So there's a line that connects our vertices, foci, and center. But if it opens up and down, our x's stay the same. So we do a line, and our y's change. So to find our vertices, If it opens left and right, that means I'm going to take my A from my center and I'm going to add or subtract A and then keep the same K. So I can keep the same height to draw the horizontal, imagine a horizontal line connecting those vertices. But if it opens to the up or down, my H stays the same. I have the same X value, but my Y's, how high or how low it is, change. So this time I'm going to add or subtract A from the K value, depending on which way our graph opens. Likewise, for foci, notice that our X's change when it's left and right. Our Y stay the same, it's the same height. And so to find my foci, I'm going to take my A plus or minus and keep the same center to get my focus for right. And to get my focus for my up and down, is that my X's stay the same, but my height between the 5 points. So H, and this will be K plus or minus C. Now, how do I find C? And remember, that was in the video. How did you find C? Good. So C squared is A squared plus squared. C is the square root of the sum of A squared plus B squared. So you add this number plus this number and take the square root of that sum. That gives you your C that you need for the focus. The question. Now, something else that was not really talked too much about in the video is on each of these graphs, say, a graph is opening to the left and to the right. It looks like this. If I figure the distance from this vertex to this vertex, so imagine if I had a line connecting that vertices to that vertex. Okay, we already figured out the center was here in the right in the middle. That's my center. And to find that vertex, I took my center and I plus and minus my A from my X value. So that meant that here was A distance and this distance A. So this entire line segment has a distance of 2A. That line segment that connects the vertices and goes through the center has a special name. It's called the transversal. I'm spelling it wrong. Check my spelling. RS. Transverse axis. Okay, this is a transverse axis. And the transverse axis always has a length equal to 2A. And I'll show you why that's important in a little bit. So the transverse axis is an imaginary line that connects the two vertices of the hyperbola together, and it always goes through the center. We also have a conjugate. Okay, I'll spell the day. Conjugate. Okay. Also have a conjugate axis. And this axis, again, goes through the center, but it is perpendicular to your transverse axis. So this would be our conjugate axis, our conjugate axis. Our conjugate axis, this distance that it goes down from the center is always equal to B. The distance it goes up from the center is equal to b. So the entire length of the conjugate axis is equal to 2b. Now, why is that important for me? That is important because if I get if I look at my transverse axis and my conjugate axis, and I draw a box around it, like this, so that this is the distance of B, this is the distance of B, that's a total of 2B, 2B, 2A, and 2A. Okay, we're always going to draw this box. The box is drawn, the axes, we usually don't draw the axes, we just draw the box. So we're going to draw this box in here. Center. Okay. The reason why that's important, that box in the center are how we're going to help us find our asymptotes. And our asymptotes dictate the width of our parabola, our hyperbolas, each of these parabolas, all right, the width of our hyperbolas. And so to draw that, all you do is you take opposite corners and you go through the center and you just connect that with a line. So I'm going to draw a line going from this corner through the center, through this corner, and out. That's going to be an asymptote. So this is one of my asymptotes. And then I'm going to do it the other direction. So corner, corner, and through the center. I was missing it a little bit, but pretty close. Would be my other asymptote. So that means my parabola is more like this. And it approaches that. So it's a little bit wider than I drew. So that's how we figure out the shape of our U's, how wide it is. So the length of our transverse axis and our length of our conjugate axis determines the width of our U's. And that's what's important about it. Any questions over that? All right, now we need to figure out the equation of these asymptotes. And so let's look, I did blue. So we're doing left and right. So if we're doing left and right, think about this. How do you find the equation of a line? How do we learn how to find the equation of a line? What's the equation of a line? Okay, y equals mx plus b is one form. Okay, that's the point slope form. You need the slope and you need a point on the graph. So if you use, you'll see it two ways. You'll see it as that y equals mx plus b is one method. And so I know one point guaranteed on each of these asymptotes is my center. So in order to figure out my b, I can use my center point, whatever it happens to be. So let's say my center is 0, 0. Okay. And so that meant I have my x and y are 0. I want to figure out my b. Well, that's easy. B is going to be 0. Okay. In this case. But how do you find slope of a line from a graph?
So next to the point, so up and over.
So we're going to look at this corner so we know it actually goes this corner. And then remember, slope is rise over run. Okay. Well, how far did I rise up? B. Because remember that conjugate axis is 2B. So I went half of that conjugate axis. I went B up. and I ran across half of my transverse axis, which is A. So my slope is going to be B divided by A, right? It's divided by run. You'll most often see it because your center will not be at 0, 0. Most often you will work with the point slope form of the equation, which you might have learned as y equals y1 mx minus x1. Oh. Okay. And so you're going to do, that's going to be y minus the y of your center, which is k. We just figured out if it opens left and right, we're going to go up B and over A for one asymptote. So it's going to be B over A, x minus the h of my center. And that, if you can do that formula, remember that formula, that'll give you your asymptotes when asymptotes. Now, what if I'm finding this other asymptote? I go down B and over A. So how does that change my slope? Negative. And so I'm going to have two asymptotes. One is going to have a positive slope, one's going to have the negative slope, but it's going to have the same slope. Now let's look at, we open the other direction, see if we can figure out the other direction. So let's say now my parabola is opening up and down. Let's just draw it as we should draw it. Okay. So I have my X and Y axis. I go, and we'll make it at 0, 0 in this case. I go this time, my Y's change, so I'm going to go up A. So I'm going to go up A. This is A. I'm going to go down A to get my transverse axis. As I'm opening up and down, my transverse axis is now connecting those two vertices. And so this is going to be A and A. So it's going to be 2A distance. There's my transverse axis. And then to get my conjugate axis, I'm going to go over B units and over B units. Remember, conjugate axis goes through the center and it's 2B. So this time it's in that opposite order. And so I have my nice pretty over. I know I hit it. Okay, so there's that box that's connecting. There's my transverse axis. There's my conjugate axis going through the center there. And so my asymptote this time is going to go like this. Does help to have a ruler. So there's my asymptotes this time. Okay. So my equation is going to change slightly. Y minus the y of my center equals plus or minus. But this time, how far up did I go? A. I went up A. I went over B. So this is going to be A divided by B, X minus H. So depending on which way it opens, which way your transverse axis runs, that letter goes is what you're going to look at. So transverse axis runs up and down, so A goes on top. Transverse axis runs left and right, B goes on top. The conjugate axis is the vertical one, and you get your asymptote. Okay, so that's all just basic. You know, I'm doing a lot of formulas here, trying to make sense of this. So let's do an example problem and see if we can put this together in an actual application problem. So here, we got x squared over 36 minus y squared over 4 equals 1. So first thing, which direction is this opening? What was that? Left and right. So this opens to the left and to the right. Because x is first. Opens left and right. Okay, what is A? 6, square root of 36 is 6. What is B? Square root of 4 is 2. What is C? Square root of 40. Remember, C is you add these A squared and B squared together. So I get 36 plus 4. That gives me 40. And then I square root them. So C is going to be the square root of 40, which is approximately 6.32. Okay, so that's my important information. All right, now let's start figuring in some information. Where is the center of this hyperbola? 0, 0. Okay. Where is the vertex? The vertices. Is the x going to change or the y going to change? Yes, because it's opening left and right, so we're moving along horizontally. So our x is going to change. So what are we going to add or subtract from the x of our center? A, which is 6. Okay, so what will that give us? 6, 0 and negative 6, 0. Those are my two vertices. Foci. Is my x going to change or my y going to change? X. My x is going to change. And what am I going to add to the center x to get, or subtract from the center x to get my foci? C. And so that's going to become negative the square root of 40, 0, and the square root of 40, 0. Or 2 to the square root of 10 if you want to write that, or 6.32 if you want to write it as a decimal. Okay, so those are my foci. Now, what is going to be the length of my transverse axis length? 12. How'd you get 12? It's our A double. So 6 times 2 is 12. And what's the length of our conjugate axis? Very good. Because that is our B, which is 2 times 2. Double that. So that it gives us 4. All right. Now we're going to sketch our graph. I'll give myself plenty of room here. All right, so first thing I'm going to do is I'm going to plot my center at 0, 0. I'll need those for the asymptotes. Label that with a C for my center. Then I'm going to plot my vertices at 6, 0 and negative 6, 0. 1, 2, 3, 4, 5, 6. That's a vertex. 1, 2, 3, 4, 5, 6. And that's another vertex. Then I'm going to plot my focus. Focus, square root, that's 6.3. All right, so that's 6.3. There's my focus, 6.3. Here's the focus. Next. Okay, I'm going to look at my transverse axis. My transverse axis is 12, so we're 6 and 6 to get to my vertex. Conjugate axis is 4. So from that vertex, I need to go up 2 to get a corner of a box, and down 2. And so I now through that vertex across. So I missed it a little bit. Through and then across. And there's that box that we draw. Notice I didn't draw the transverse conjugate or the transverse axis or conjugate axis, but you can see the length there of those to get to that. Okay, then you want to draw your asymptotes in. Oops, that one's I'm doing. Rulers help. Yes, okay. So there's my asymptote. So from my vertex, draw a U approaching that asymptote. That's how you get your graph. So we got our graph done. Questions on sketching the graph. The only thing left is now we need to go to the equation of our asymptotes. Right. So that's going to be y minus the y of our center, which is 0. And in this case, I've gone up 2 and over 6. So what would be my slope? 1/3. So plus or minus 1/3. X minus 0. Simplifying that down, that gives us y is plus or minus 1/3 x. There's the equation of the asymptote. We finished up that part. Questions over this? Okay, go ahead and open up Canvas, Conics, Hyperbola, and do problems 1 through 4. 1, 2, 3, and 4. This is what I want to see. This graph here is what I want to see. It's pretty much what this work is all the work I want to see on your paper. This is a good example of the work to show for each problem on your paper. Which I'll be submitting that. That we might have. And this is when you're given the equation in general form. So for example, let's say we're given the equation 4x squared minus 24x minus 25y squared plus 250y minus 489 equals 0. Okay, so given the equation in the general form, and so we have to first convert it into our standard form so that we can identify our key points of our function and so that we can graph this hyperbola. So this is going to be very similar to the process we did for ellipse, except in this case, it's not always going to be the x squared terms together first and the y squared terms. You're going to look at and figure out which term is positive, which squared term is positive. You're going to write those first. So in this case, my x squared term is positive. So I'm going to write my 2 x's first and then my y. So always write the positive squared term first. So that's going to be 4x squared. I'm going to group that with the other x. So it's going to be minus 24x. Then I'm gonna put my y's together, so it's negative 25y squared plus 250y. And then I'm gonna set it equal to the constant. So move the constant to the other side of the equal to sign. And then remember, to set up our blanks, we need the coefficient in front of the x squared to be 1, and coefficient in front of the y squared to be 1. So from the x's, I want to factor out a 4. And so when I divide by 4, what does that leave me in for my x terms? Okay, so it gives us x squared minus 6x. And I'm going to put in my blank. And then for the y terms, what am I going to factor out? Negative 25. And so what does that leave me with? Y squared minus 10y. So make sure you factor out a negative 25. So your sign always changes there for that y term. Plus blank equals 489. Now, normally with the ellipse, I did plus blank minus blank. If you notice, this term times this positive is going to give me a positive. So I'm going to plus that term. But positive here times a negative will always give me a negative. So I'm actually subtracting that second term. So I need to subtract the second term here. So my second blank needs to be a subtraction. And then I'm going to do something squared and something squared. Find out what the signs are. And then equal to our number. All right. So what goes in this bottom blank here? Negative 3. So I took that negative 6 and divide by 2 gives us negative 3. This top blank. Negative 3 squared, which is 9. And so 9 times 4 is what I'm going to add over here. So 9 times 4. 36. Then I'm going to repeat for the y's. So negative 10 divided by 2 gives us, that's going to be a minus 5. Negative 5 squared, 25. Okay, 25 times a negative 25, 625. So that's that minus 625. Now I need to combine these terms. So figure out what 489 plus 36 minus 625 is. Negative 100. So far so good. Now, what's our next step? Same as the ellipse. What will we do next? Divide everything by negative 100. This has to be a positive 1. So we're going to divide everything by negative 100. All right, so 4 divided by negative 100, what does that simplify down to? 25 on top or bottom? Bottom. Okay, so that gives us x minus 3 squared, that's negative over 25. So it's negative, negative becomes positive, right? Okay, and 25 over 100, 1/4. So that gives us y minus 5 over 4 equals 1. Oh no, look, my positive term is no longer written first. My sign's changed. So I now need to rewrite this so that my positive term is written first. Oh, my square. And my negative term is written second. There's the standard form of the hyperbola. All right. So let's answer our questions over this. Let's find our key values and answer the question. Now we got this. What is our opening direction? Up and down. Okay. What is A equal to? 2. Very good. Square root of the 4. What's B equal to? 5. And what is C equal to? Square root of 29. Okay. So just draw this little picture to help me think about this. I know I'm opening up and down. So I know, here's my center, I know my vertices need to be on the same X value as my center, but the Y's change. So what would be, well, what's our center? Okay, X is 3, Y is 5, very good. What is our vertices? Very good. So we take the same, which since it's vert up and down, the X stays the same, so I need to add A, it's always A. So if A is 2, I take this and add it 2 to my 5, which gave me 7, and then I do what? 3 what? 3, 3, because you take the 5 and subtract 2. And that gives you that. Okay, foci. What would be my equation of my focus? Let me give myself a little bit more right here. Okay, so that's 3, and then that's 5 plus the square root of 29. We convert that into a decimal. And then what's this one? And convert that to a decimal. So that's going to be our foci. 3, and then 5 plus square root of 29, and 5 minus square root of 29. All right. What's the length of our transverse axis? 4. A squared. A times 2, which is 4. Okay, and the length of our conjugate axis? Very good. Which is B times 2. So 5 times 2 gives us 10. All right, now let's sketch our graph. Spacing is not very good on this one. Okay. So I have opens up and down at the center at 3, 5. 1, 2, 3, 4, 5. Sorry, 1, 2, 3, 1, 2, 3, 4, 5. Okay, so the center at 3, 5. Vertices at 3, 7, and 3, 3. Okay, there's my 2 vertices. Foci, we actually forgot that decimal value there. They're out 5 plus root of n. Very good. So that is n. One, 2, 3, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.4. Okay. So that's our focus. And then we have where we did the subtraction, what do we get? Okay, then you got negative 0.4. So there's my other focus. Okay, and we know we've gone, here's our transverse axis here, connecting the 2 vertices. Okay, and what was our conjugate axis length? 10, so I need to go 5 in each direction from the center. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Those are 5. Okay. And 1, 2, 3, 4, 5 in each direction. So our vertices, our vertex, our vertex, our vertex. A little off there. A little off there. But that's our basic shape. Okay. And so diagonal. So vertex. So notice that farther, this focus was farther away, and look how spread out and flat our parabola is. So the farther the focus is from the vertex, the more wider your graph is going to be. This is a pretty wide U-shaped graph, very wide graph. Okay, now equation of the asymptotes is the only thing I got left to do. So to find my equation of my asymptotes, I got y minus the y of my center, which was 5, equals our slope, and x minus our x of our center, which I believe was 3. Okay. And then to get our slope here, we went up a and b. So our a is 2, b is 5. So a plus or minus 2/5. That's our equations of our asymptotes. Any questions over that type? It changes just slightly. All right, finish up the worksheet.